welcome back to class. I'm Miss Algebra. So happy that you could make it. Today, we are continuing in our series on algebra foundations. We are covering two-step equations today. So excited about this lesson. This is pretty much the meat and potatoes of Algebra 1. This is what everybody thinks of when we talk about Algebra 1. When someone brings up algebra, they think about solving equations. This tends to be it. There's a couple other things that come to mind, but this is definitely one of the big ones. I think I have everything that I need. If you have your guided notes, go ahead and open them up now. If you don't have the guided notes, you can actually access them at the link down in the description box below. You can get this individual lesson, or you can actually get a bundle of 6 lessons that all are algebra foundations related. So I would totally check that out because I made it all. But yeah, let's go ahead and get started. As always, hold on. Okay, there we go. As always, we are going to start with the learning target. Here it is for today. Our learning target, I can solve two-step equations using inverse operations. Last time we were together, we were doing one-step equations. So we're moving right along. In fact, for our do first, they ask us to solve each one-step equation. So they want us to just kind of recap what we were doing last time. So let's talk about it. Our first one is x plus 9 equals 18. Some of you may be asking, why are you rewriting the problem? I need to see the original problem, and then I have to start like all of my calculations because I'm going to mark it up. I like to do a lot of annotating. I am a show your work kind of girl. So that's definitely it definitely just helps me not make my work too messy so I can go back and see what I originally had. So we're starting with x plus 9 equals 18. I need to make a zero pair. I'm doing that because I know that opposite values add to zero. So I'm going to subtract 9 here. That's going to give me 0 on this side. I'm going to subtract 9 over there. That gives me x equals 9. Of course, I can always check my answer by substituting it back into the original equation. I'm not going to do that for now. We're just going to keep going. Our next one is 5m equals negative 35. All right, this time we are multiplying our coefficient and our variable there. So we need to divide. I actually should be using different colors to try to make that a little bit easier for you to visualize. 5m divided by 5 is going to be 1m, or just m. And then I have a negative divided by a positive. I like to draw this little symbol up here. It helps me remember my positives and my negatives when I'm multiplying and dividing only with those. So a negative divided by a positive leaves us with a negative. So I should be expecting m to equal -7. All right. Last one, r over 6, r divided by 6 equals 8. Again, we're dividing. We need to do the inverse operation so that our coefficient is like 1, right? Being multiplied by 1. So I am going to multiply by 6 on both sides. That gets rid of that denominator for me. 6r divided by 6 is 1r, or just r. And r is going to be equal to 48. Again, you can check by going back, substituting into the original equation. We have time. We don't have time. We're going to move on. I trust you there. All right. As always, I'm really big on talking about math, not just doing math. So I do want to make sure that we cover the vocab. That way we know what we're talking about. We sound like we know what we're talking about. People want to hear what we have to say. All right. We're going to keep it real short, cute, and sweet this time. Constant. A constant is a number without a variable. A number term, throw that in there, without a variable. Perfect. All right. Our next term is coefficient. You may remember that from previous lessons. This is the number that gets multiplied to a variable. Multiplied to a variable. So if I had a phrase like 6x, 6 would be the coefficient there. All right. Inverse operations. We talked about this the last lesson as well, because in order to solve our one-step equations, we have to use those inverse operations. These are operations that undo one another. And I don't really like to make that definition any more mathy than that. The operations undo one another. I feel like people know what that means. And then we have solution. The solution to an equation is the value that makes an equation true. All right. Perfect. All right. Before we go any further, we have to talk about our big idea. So let me come back so that you can see me. We can chat a little bit. All right. So whenever we are solving two-step equations, we have a couple of things going on. Generally, we have our variable that we start with, and they will multiply or divide that variable by some amount, and then they will add or subtract from that product or that quotient. So we have one like a set of like smaller operations happening, right? Addition and subtraction. Excuse me. And then we have a set of our larger operations happening as well, multiplication and division. So, in order for us to solve these equations, we are going to make zero pairs with our constants first. It's really easy to just do a quick one-off addition subtraction. So we're going to make zero pairs. Remember that opposites add to zero. Then we are going to make the coefficient for our variable equal to 1, because 1 times anything is itself, right? So we're going to undo the addition or subtraction first. Then we're going to undo the multiplication or division. All right, let's go ahead and write that down in our big idea box, because that was a lot. Okay, so here is our big idea. We're going to solve equations by making zero pairs with constants first, then make coefficients equal 1. All right, so zero pairs first, coefficients are 1. All right. think I want to jump down to this keep in mind box next. So, couple of things. Last time we were simplifying expressions. Before we started equations, we were simplifying expressions using combining like terms, distributive property, right? Expanding and simplifying. Whenever we do that, we tend to follow the order of operations. So, we're going to follow the order of operations when we are evaluating expressions with no variables, right? And evaluating expressions with no variables. Okay, so if I just gave you like a random, excuse me, if I just gave you a random expression, we were using like order of operations, PEMDAS, BODMAS, however you do order of operations, we would do it that way, right? We wouldn't have any variables. We're looking for a final answer. When we are trying to solve an equation, we're looking for a value to fill in for that variable. We're actually going to do them in reverse. So we're going to do the order of operations in reverse order to isolate our variable. All right, perfect. We do have the order of operations here on the side, so that'll help you understand why I said we need to make those zero pairs first, right? Our very last step, whenever we're doing order of operations, is to add or subtract from left to right. So we're always going to look to do that first, make those zero pairs, then we can divide or multiply. All right, let's take a look at our examples. We have a couple of them to go through. Here's our first one. 3x plus 5 equals 20. All right. So notice that we have multiplication here. That's the 3x part. Then they are also adding 5. We said we were going to undo the addition or subtraction by making those zero pairs first. So I'm going to go ahead, go ahead and subtract 5 on both sides. That makes 0 for me here. And now my next line says 3x equals 15. Now, at this point, we're doing, again, the inverse operation like we were doing for our one-step equation. So now we are multiplying x. That means we're going to divide by that coefficient 3 so that the coefficient is now equal to 1. And now our final answer is x equals 5. Okay. Moving right along, going down to example 2. I'm going to start again by making that zero pair. I need all the constants together. So my variable right here is kind of tied up with that division, so I'm going to leave that alone. But this constant, -6, I can go ahead and make a zero pair so that I have all of my constants over here on the right side of my equation. So I'm going to go ahead and add 6 to both sides, plus 6 plus 6. That makes 0. All of my constants are now together. And I have this, so x over 4 equals 15. Now, x divided by 4 implies division, so we need to multiply by that denominator so that x is alone now. So we're going to multiply both sides by 4. 4x divided by 4 is just 1x, or x, and x is going to be equal to 60 for this example. All right, here's our next one. Ooh, this one says negative x plus 9 equals 37. So that negative lets me know that you could, technically they're multiplying, so you could multiply by -1 or divide by -1 in order to work around that. But we're going to start by making a zero pair with that 9. So subtract 9 right here, subtract 9 here. Here is 0. Again, I like to show the zero pair. That way I can see what I'm doing and why it went away. So negative x is going to be equal to, ooh, 28. And now, because we are multiplying by -1, I'm going to divide by -1 just so that it's the opposite. This basically says the opposite of x is 28. So that's going to become 1, and x is going to be equal to -28. Again, the opposite of x is positive 28. That means x has to be -28. Moving right along, example 4, you knew I was going to bring out those decimals. Want to make sure that I keep exposing you to them so that they're not like unfamiliar or scary when you see them later. So we also have a little bit of division there, x divided by 5. First, we're going to start with that zero pair, means we're going to get rid of 3.4, 3 and 4 tenths. We're going to subtract that on both sides of my equal sign. If it helps, I know some people like to draw a line to separate the left and right sides of your equations. You can do that. It is not in my practice, but you're welcome to do that if it helps you. However you want to get there is fine by me. This is going to be 4.4. All right. Now, again, because we were dividing x divided by 5, we need to multiply. It takes 5/5 to make a whole. So we are going to multiply both sides by 5. 5x over 5 gives me 1. And x is going to be equal to, I believe this is 22. If I'm not mistaken, 22. Yep. All right. Last example in the guided practice. You got it. I think by now you know what to do. We're going to make that zero pair, right? We need to make zero pair with 8. It's real easy for us to just subtract 8 on both sides, get all of our constants on the right side of that equation. Here is our zero pair. We now have 4x left equals 14. Okay. We're going to divide by 4 on both sides since we were multiplying to get 4x. 4x divided by 4 is 1x. And x equals 14 over 4. I do want you to also be okay with sometimes our answers are not going to be whole numbers, right? Sometimes they're going to work out to be decimals or fractions. We got to be okay with that. So x is going to equal 14 over 4. But I would simplify that knowing that both values can be divided by 2. So 14 divided by 2 is 7, and 4 divided by 2 is 2. So our final answer is going to be 7 over 2. You do not have to convert this into a decimal. Once you have it as a simplified fraction, as long as you can't simplify that fraction anymore, even though it's improper, you can leave it. It is mathematically correct. I would also be in the habit of just matching whatever form I was given. So in this case, we started out with whole numbers. So I'm going to actually just leave it as a fraction. If we had started out with decimals and it had worked out to not be a whole number, I would leave it as a decimal, right? So if they give us fractions, try to keep the fractions. If they give us decimals, try to keep the decimals just for continuity's sake. All right. Let's go back. Before we get any further, I don't want you making any mistakes. So we're going to jump down to the common mistake box. Please, 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 because I've already been in a fairly bad habit of this so far in this lesson. You need to check your answer using substitution. I'm going to actually write that in red. I'm going to write it in red, and I'm going to say it to you here, camera only. Please be sure to check your answers using substitution as often as possible. Thank you. Okay. Let's go back. Let's write it into our notes. Don't forget, stop on your right foot. Don't forget it. Don't forget to check your answer. Woo. Using substitution. All right. For the next part, you are going to have to check your answer, so just be aware that that's coming up. Before we get there, let's talk about this here, this or that. Two students are solving the same equation. Here's our equation, 4x plus 8 equals 36. So student A subtracts 8 first. Student B divides by 4 first. Who's correct? Explain your reasoning without solving the equation. They do not want us to solve here. Okay, a couple of things. I know that student A is on the right track because student A is looking at making a zero pair with that 8, and that would mean that we would need to subtract 8 first. Very cool. However, I also notice that all of the numerical values in this equation are multiples of 4, meaning we can divide them all by 4. That means that if student B chose to divide by 4 first, that also makes sense. I could go backwards, use the distributive property backwards, and simplify that equation. So I kind of understand what they were going for. Again, they don't want me to solve the equation, but I don't know. What do you think? Can they just divide by 4 like that first? Like, don't we have to make the zero pair first? I don't think so. I do think that because all of the terms can be divided by 4, you can divide by 4 first as long as you do it equally on both sides, right? So both terms over here, like everything has to get divided by 4. Um, I would probably go for subtracting 8 first. It's just me, like just because I'm in the habit of making those zero pairs first. But technically speaking, they're both correct. So let's go ahead and give them both their props. Both students are correct. Because all numbers in the equation can be evenly divided by 4. Personally, like I said, still recommend subtracting 8 first, but I I get it, right? So this could be 4 times x plus 2 equals 36. Again, they don't want me to solve it, so I'm just gonna leave it there. But you see what I was going for, right? The distributive property. All right, let's try it out. You only have to do it twice because I know that y'all don't like to check your work, and I know it's like, it's a lot. It feels like a lot. I got you. I got you. So do 2 problems, check your work for those 2 problems. And I did one of them for you. So technically it was 3 problems, but I did one for you. So you're welcome. All right. Here is our example. Let's take a look at it. We have 4x plus 10 equals 34. They subtracted 10 on both sides. That's that 0 pair. And now we're left with 4x equals 24. They divide by 6. Ooh, I need to change that. It's going to be divide by 4 on both sides. Gross. Divide by 4. I will change that in the documents now that I see it. And x is going to be equal to 6. Then they come back and they check their work, and this is why we are always checking our work. Uh, they write out the equation 4x plus 10 equals 34 if x equals 6. They go ahead and replace x with 6 and then evaluate from there. So 4 times 6 is 24. When they add 10, they get 34. You do have to write 34 equals 34 at the end. It is tedious. It is redundant. It is important. Sorry. All right. So let's take a look. Ooh, let's do the first one. Let's do the top one first. All right, 9 equals x over 4 plus 4. Okay, let's get my blue pen back. First thing I'm going to do, make a 0 pair. And I'm going to do it with 4 right here. So that's 0. Here's my next line. 5 equals x over 4. Okay, my next step is to get rid of that denominator. I need 4/4 to make a whole. So I'm going to multiply both sides by 4. And this gives me 20 equals x. Now, remember, they want me to check my work. So I'm going to rewrite the equation that I have. Check 9 equals x over 4 plus 4 if x equals 20. And then I can go ahead and substitute. So 9 equals 20 over 4 plus 4. 9 equals, this is equal to 5 plus 4, and then 9 equals 9. That checks out. All right. Here is our next one. It says negative 8x plus 14 equals 34. All right. Starting with that 0 pair. If I have 14, I need to take away 14 to get back to 0. That's good. Now we have negative 8x equals 20. I need to now, because we are multiplying in the equation, I need to divide by that coefficient. Remember to divide out the negative also. That gives me 1x on my left side. And x, this can be simplified. Again, 20 over negative 8, I am going to have a negative number. Positive divided by negative is negative. 20 over 8 is going to be 10 over 4 is going to be 5 over 2. And I don't have to keep dividing that out. I'm going to leave it like that. Perfect. Let's go ahead and move on to the check. You're going to check by writing the original equation again, plus 14 equals 34 if x equals 5 over 2. I'm running out of that box. It's okay. I'm gonna say -8. I'm gonna plug this in 5 over 2 like that, just so that you can see it. Plus 14 equals 34. When I multiply this, I get -40, sorry, -40 over 2 plus 14 equals 34. And then this is, I made a mistake. This should be -5 over 2. And this is why we check our work. Remember, our answer was negative. So I should get a positive number here. Positive 40 over 2 is going to be 20. There we go. Plus 14 equals 34. And we do get 34 equals 34. Right. Brilliant. Okay, last thing here. Quick question, just something I would like to know. In your own words, let me move myself out of the way. Right. Explain why making a zero pair with our constant first makes the variable easier to isolate. That is a little bit weird to think about. Remember that last problem that we talked about? You didn't have to um, do this first. And in fact, I wanted to talk about that in the check here because this problem I could not have divided by 4 first, and I would not have done that. 10 can't be divided by 4 evenly. I could divide it by 4, it'd be 2.5, but because I can't divide every single term in this equation evenly by 4, I would not do that. You could divide it all by 2, but that doesn't move us toward like solving the equation any faster. Whereas with this one, because every value could be divided by 4 evenly, it made a lot more sense if you wanted to do that as a first step. But for the sake of the question, you're explaining why making a zero pair with the constant first makes the variable easier to isolate. Would love to hear your thoughts on that. Here's kind of what I thought. Just you want to like actually solve the equation. If I just divide it by something random or multiply it by something random, I can write an equivalent equation, but it doesn't get me toward isolating the variable anymore. So whenever I'm making that zero pair with those constants, I'm actually making it so I only have one more step left to isolate the variable. So making the zero pair first, at least in my opinion, making the zero pair first makes the equation have only one step left to isolate the variable. All right. Lovely. Well, thank you for joining me. I'm sorry, like the sun is going down. It's getting dark in here. So we're going to go ahead and wrap this up for today. But I really hope that that helped explain, break down two-step equations for you. Like I said, if you want to get these guided notes, you can access them at the link that's in the description in the video below where you're watching it right now. Um, if you would like to get the entire bundle, you can do that as well. I definitely recommend it if you're looking for like a full progression of lessons. Each guided notes activity comes with these notes that we just talked about in the video, plus an independent practice activity, plus a fluency check, plus an answer key, plus an exemplar. So you get the actual version that I like wrote, like you will get the writings that I have as well. Obviously, you're watching the lesson on YouTube. There's a digital version if you like to teach via Google Slides or Google Docs. I try to think of literally everything for you. So this is pretty much like ready made for you to go. But I will see you next time. Y'all have a great one. Be safe. Until next time. Okay, see you next class. Bye.